Yeah. Today our lecture is about some continuous distributions. As per plan, we have to complete these distributions by the end of fourth lesson, fourth week. So that's why I have not covered the negative binomial geometric in the last session, in this session. So today we will talk about and study two continuous probability distributions. Two continuous distributions. One of them is uniform probability distribution, which is the very most simplest distribution in continuous random variables, and the other one is exponential distribution. in in practical, you have used exponential distribution in your physics lesson, and you have studied exponential distribution in integration chapter. It's in second A level, AS level, at A level and AS level. I think either A or AS level they have studied. So as a review, as a recall from lesson 1, you have studied for a function. Suppose you are given a function, mathematical function. Is it possible to show that that function is a probability distribution? So for that purpose, we require two conditions to be satisfied. Number one condition is that the function values must be positive. Fx greater than equal to 0 stands for that if you put different values of x, the answer of the function should be either 0 or greater than 0. This notation is called for all. For all values of x. This says that for all values of x, this sign says belongs to D. D is the domain set. So for example, in last class, we studied a function. In lesson 1, we studied a function where the domain was x greater than equal to 0. That means 0 to infinity. And in some functions, you will study, for example, x from 1 to 3. So that means the domain is a set of all values from 1 to 3. 1 up to 3. So this is the notation for all. This is for all x that belongs to the given domain. For example, you can have different domains for different functions. So if you want to satisfy this condition, we have to say that we put different values of x from the domain set, and for all x values, the function is positive. Then second condition, if you integrate the function from the lower limit of x to the highest limit of x, for example, maybe you will study some function where the limit is minus infinity to plus infinity. You studied in lesson 1 or lesson 2, there was a function that had limit 0 to infinity. So you will find different functions may have different limits. And if you integrate that function, the answer must be equal to 1. This is called area under the curve is 100%. So that means there is nothing left when you integrate the function from lower limit to upper limit. Whole thing is covered. 100% means 1, or everything is covered in that area. We also studied how to calculate mean, lesson 1 or lesson 1. Expected value of x is the mean. We integrate from x is equal to L to U. L is the lower limit, U is the upper limit, x times fx dx. And for the variance, we have to calculate expectation x square, which is simply, if it is x square, you will put x square here to solve this problem. So this is simple, the variance term. And you know the standard deviation is simply the square root of variance. We can find the standard deviation as well. We will need standard deviation terms in our next session, in next lesson next week. Median is the most middle observation of a data set. So if we integrate some function, suppose this is a probability distribution, we integrate this function from lower limit to upper limit, and it says, so not upper limit, lower limit to some point m, where m represents the median value of this function fx. We say it equals half. Why it is half? Because median is the most middle observation. That means half of the region will be on the left hand side of that point, median point, and half of the region will be on the right hand side. Or in other words, we say half of the area will be below that 50% point, the point showing 50%, and half observations will be above that point. So that's why this is a median value. Sometimes we rely on mean, sometimes we have to depend on median. So it depends on what is the data type, and what is the shape of the histogram. That's a practical type thing. Kth order round movement we studied in first lesson, that we can calculate in place of power x equals 1, in place of calculating x expectation x square, we can directly calculate expectation for x power k, which is we have to integrate from lower limit to upper limit x power k x fx dx. Just replace x with x power k. X power k is here, so x power k is here. So this is the things, these are the things that we studied in our previous classes. Now today, this slide is showing some of the common distributions. For example, continuous uniform is a common distribution. Exponential distribution is very useful and very common in real life. Normal distribution is the most, it is like the spine of the statistical analysis. If your data is not normal, that means you have to play with the data and then make it normal, or otherwise you have to use some other statistical methods. So this is the core, this is the fundamental concept that whatever you do, even when you will be studying artificial intelligence and machine learning, you will find that if your data is not normal, your machine learning or artificial intelligence algorithms, they won't work properly, and they will mislead. For example, if you are a professional in data science, so those results will mislead you, misguide you. Triangular distribution you will study in AI, and binomial distribution, discrete binomial distribution we covered last time. We are not covering geometric and hyper geometric negative binomial. So we covered Poisson. So because of we have more content, so we will consider only few of them. These are few distributions, of which chi-square distribution is another very important distribution, which is related to normal distribution. We will study the student distribution, student C distribution, we will see them. And because we have limited time, so we will not be able to cover everything in the lesson. First thing is uniform distribution. Uniform distribution is a first continuous probability distribution, and it is having the form fx equals 1 divided by b minus a, where a less than x less than equal to x less than equal to b. That means a and b are some constant values. So for example, if I suppose b is equal to 10, a is equal to 5, so the function will be 1 over 10 minus 5. It will be 1 over 5. It is a very simple distribution. Suppose b is equal to 50, a is equal to 10, so it will be 1 over 50 minus 10. That will be 1 over 40. So that means this function depends on the two parameters a and b. And then if we have, that x values are on the x are pointed on the x-axis, and fx equals to y is pointed on the y-axis. So the width of this distribution showing the lower limit a, the starting point a, and the finishing point b, and the height is represented by 1 over b minus a. For example, 1 over 10 minus 5 is 1 over 5. This is making a rectangular shape. So that's why some authors also write it as rectangular distribution because of this shape. A is the location parameter because it defines what is the starting point of this distribution. For example, a is equal to minus 10. So the function will start from the negative x-axis, left side of the x-axis. And if it is positive 10, so it will start from the positive side. So, and b minus a is the scale. Scale means spread of this function. For example, if it is 10 minus 5, it is only, the width is only 5, or spread is only 5. And if it is 50 minus 10, the spread will be 50 minus 10 is 40. So the scale or the spread of the distribution depends on B minus A. This is some of the characteristics. But if we very simply consider that B is equal to 1, A is equal to 0, it will be 1 over 1 minus 0 equals to 1. So this is called a standard uniform distribution. And yeah, that's it. For X between 0 and 1 inclusive. You know, in a continuous distribution, if I write X less than 0, and if I write X less than equal to 0, you will see that there is no difference on the integrations. Because I think you know, if I want to integrate a function, suppose 2x, function is 2x, I want to integrate it from 5 to 5. Lower limit is 5, upper limit is 5. If I integrate that function, because the lower limit and upper limit are same, the integration result will be equal to 0, because integration always calculate area. It do not work on a single point. So this is one of the reasons that is called point integration is 0. So that's why in continuous distribution in statistics, if it is written less than 0, x less than 0 or less than equal to 0, they will have similar meaning. But there are limitations. Okay. I found a very good website that you can use to play with the parameters of this distribution. I will first cover my lesson, and then I can show you how to visualize different shapes of this function and how to play with changing the parameters and what will be the mean variance. So that's GeoGebra is a website that let tutors to make their lessons visual, like Java applets, and it's very funny. It's so fun, like you can understand the statistical concept in visual effects with visual effects. Okay, following the concept of mean, we have expected value of x equals x lower limit is a, upper limit. Where from this lower limit upper limit coming to us? It is showing x has lower limit a, upper limit is b, and second line is showing the function value is 0 for the function value is 0 if the value of the x is beyond this limit. That means x less than a or x greater than b, then the function is 0. This is called otherwise, or this is also called elsewhere. So in place of writing otherwise or elsewhere, I have placed the actual reason why the function is 0 after between a and b. Okay. So x lower limit is a, upper limit is b, and you have seen in first lesson, and maybe you have worked your assignment yourself, then you know that x times fx. So I just say x times 1 over b minus a. You know, integration says remove the constant from inside the integration, put it outside. Integration of x is x squared by 2. And then you know b square minus a square. It's the formula that you studied in school level. It's the difference of two squares. That answer will be b minus a, b plus a. So b minus a will cancel with b minus a, and b will be given b plus a over 2 or a plus b over 2, which is the mean value of the uniform distribution. That means it is simply says if you want to find the mean value, you add the upper limit and lower limit and divide by 2. Simply. So in the terms, the second thing, expectation of x square. So we will integrate the function from lower limit to upper limit, x square fx, and same with the simplest previous step. It will give me x cube over 3 and 1 over b minus a, b cube minus a cube. So it is a difference of two cubes. If I am not wrong, it is b minus a and second bracket b square plus ab plus a square, and b minus a will be cancelled with this b minus a, and so we will have the leftover is b square plus ab plus a square over 3. This is you know this formula from your school, and so you can use it. And I'm sure you did not pass your metric by online education. You have studied. And finally, the variance is expectation x square, which is given by this formula. Expectation of x whole square, which is given by this formula squared. Then this is DIY is a very pretty term which is used for assigning students some work during lesson. So it is do it yourself. So you will do yourself. That means I can ask something like this in exams. Next is how to define the kth order raw movement. That's another way, because you see, if I want to find mean, I have to integrate the function. If I want to find second order mean that is expectation x square, again I have to integrate. So why I have to integrate again and again? There must be some way, simpler way to at one time and reduce the repetitive work. So here, this is a kth order movement which is used to reduce the repetitive work. Expectation x power k times fx, and integration from lower limit to upper limit. And so x power k over 1 minus b minus a, 1 over b minus a. Then integration of x power k will give me x power k plus 1 by k plus 1. The limits are a to b. Then it is the difference of two higher order formula, like k plus 1 and b power k plus 1, a power k plus. And so how to find the mean value? So for mean, you will put k equals to 1. You can put k equals to 1 here and here, and k is equal to 1 here. Then you will find that the mean value will be a plus b by 2. And similarly, you can find the variance using this function. We already have seen what will be the answer. The mean should be this, and the variance should be this. So using this formula, we'll put k is equal to 1 and k is equal to 2, get expectation x square and expectation of x whole square from this formula. Okay. Any questions? If you have any question, otherwise I will. Okay. So next is median. Median defines the most middle observation of a function. Here we say of a probability distribution. So x is equal to a to x is equal to m 1 over b minus a. So remember, in higher classes, you don't need to write the differential. This is called differential, dx. When you will be in higher class, now you are in higher class, then you don't need to write dx every time. It is understood because I am using the limit of x equals to a, x is equal to m. It is understood that this is the integration for x. So we don't need to write dx, and we can save space. So equals to 0.5. And when we integrate it, we will have m minus a over b minus a and equals to 0.5. And then we get the formula, which is m equals lower limit is a plus b minus a times 0.5. It's a simple formula for finding the median because it is a linear distribution. It is a linear distribution. Linear means there is no exponential, no x square, no reciprocal or logarithm. So this is a linear function or linear probability distribution. Okay. Cumulative density function or distribution function. We have seen what is cumulative density function or cumulative distribution. Sorry, cumulative density function or distribution function. It is a cumulative probability. For example, I want to find the probability of x. So sorry, probability of x less than equal to some specific point x. I don't know what is this x. This x must be within the domain of the set x. That means if this function is from a to b, so this x value must be between a and b. It cannot exceed outside a and b. If it exceeds outside a and b, for example, if it is a, suppose a minus 5 or a minus 10, then we will say probability will be 0. because you can calculate probability only between A and B. How to do that? In place of upper limit, we put x. X is a value which is between 0 and 1. Sorry, between A and B. So when we integrate it, we have x minus A over B minus A. And so we have function like this, which says the CDF value, the CDF function has the value x minus A over B minus A if and only if the x lies between A and B inclusive. Otherwise, if x is less than A, the answer is 0. And if x is greater than B or greater than B or equal to B, the answer is 1. So basically, CDF is same as a cumulative probability. Whenever we say cumulative means we add up the previous probabilities into the current probability. That's why it is called cumulative function. You see, from any point 0 or negative infinity till A is 0, then we have a straight line because it is a linear function. This is a linear function. It's a linear equation, x minus A over B minus A. And then after reaching B and so on, it remains 1. So fx have upper limit always. This is always true that fx, the CDF function, will have upper limit 1 and lower limit 0 and some function between 0 and 1. So this is a standard approach of presenting a CDF function. We show the lower limit, we show the highest possible limit, and we have one function or maybe more than one functions within 0 and 1. If it, yeah, I think we did not did the CDF for piecewise functions. You can see. Okay, this is very important property in uniform distribution, that random number generator. You know, random number generator, it is used for every programming language, operating system, any database, every software that you use on a computer. They have their own random number generators. These random number generators are used for allocation memory. They are used for allocation space on the hard drive. So there are many different applications. And yeah, cryptography in hardware side, anywhere in virtual reality and augmented reality, so artificial intelligence. So these are the fields, some of the fields that I know. There we use a random. And sometimes you want to have different answers in video games. For example, you want to play a video game and you want every time a different configuration of the enemies and friends. So we use random number generators, constraint of random number generators. The fundamental concept of random number generators comes from uniform distribution. You know, this is the CDF. This is the CDF, and we equate the CDF. And we equate the CDF this CDF x minus A over B minus A, and we suppose CDF is called U is equal to U. We call it U, and we solve for x. You know, U equals x minus A over B minus A. Then we solve this equation, it's a linear equation. So we have A plus B minus A times U. This is called a random number generator for uniform distribution. What is U? U is the standard uniform distribution. Yeah, it was where U follows. This is the notation for representing uniform distribution. U follows uniform distribution where the lower limit A equals 0 and upper limit B equals 1. So we have uniform random numbers from standard uniform distribution. We use the standard uniform random numbers, and then we have some other limits. For example, A is equal to 10, sorry, A is equal to 5, B is equal to 10. So we can generate random numbers from any other function which is not having limit 0 and 1 and generate them for uniform distribution. Second thing, these random numbers from uniform distribution are the fundamental concept concept for generating random numbers from other probability distributions. You will see this in practical. You will see this in semester 6 in module simulation and modeling. So any system that you want to design, you have to use random numbers for testing. I think you know, you have seen when mega engineering projects in a TV channel, and they simulate a situation. For example, Burj Al Khalifa, I don't know, sorry, name. So the UAE constructions, they simulated everything first with constraint satisfaction problem, and then they simulated the building and they developed it. And you see they have large, very large buildings, stable buildings. So these are very fundamental but very practical concepts. It is out of scope to go into practical side, so we will focus only on the statistics side. Question number 1. Okay, any question from anybody? Then and then I proceed. Okay. Question number 1. I think I have one question, and second, consider the uniform distribution. Suppose the lower limit is -1, upper limit is 1. That means A equals -1, B equals 1. So 1 divided by 1 minus -1 gives me 2, 1 over 2. First question is, I want to find the probability. What is the probability that the x can take value from -1 by 2 plus 1 by 2? What is the chance of having this situation, -half and +half? Even the example is one of the example of simulation is transportation, supply chain managements, where you simulate the situations, how to supply which item to which country, which item should be placed at the bottom, which should be in refrigerators. All these are constraint satisfaction simulation problems. Very, very practical things. In SCM, there are few people who can do it worldwide. Okay, so -1 by 2 to +1 by 2. This is a lower limit. This is the upper limit. Sorry, this is the lower x value here, and this is the upper value of x. Not the limits are -1 to +1. 1 by 2 dx. Then we simply, integration very well. 1 by 2, upper limit minus lower limit is -half. When I solve it, I get mean equals 1 by 2. X greater than equal to half, then we will have, greater than equal to half means from half to infinity. So the problem is that we do not have upper limit infinity in this case. The upper limit in this case is +1. So what I did, I put it here like this, half to 1. I am not using infinity. Infinity, I just showed you here to say that when it is saying x greater than equal to half, that means from half to infinity. But because your function is only available from -1 to +1, so I replaced this infinity with 1. That means your infinity in this function is equal to 1. You don't have to go beyond this. If I go beyond 1, the probability distribution is 0. That will be the otherwise case. And simple integration, then we have the answer 1 by 4 for the probability of x greater than equal to half. Similarly, following the same formula that we did in previous slide, mean will be a plus b by 2, variance will be b minus a over 12 whole square. You just need to put the values and verify this. And median is equal to lower limit plus 0.5 times upper limit minus lower limit. So they are very simple, so I did not solve everything. This is useful. See, it is asking you to find a probability which is away from given limit, because your domain set is -1 to +1, and this is asking beyond the domain sets values, -10 to +10. What I did, I split it into 3 pieces. What is the probability if it is less than equal to -1? You see, less than -1 is 0, not available. Then what is the probability of x greater than equal to 1? You see, this function is available only between -1 and +1. So that means the probability of having x more than equal to 1 or greater than equal to 1 is again 0. only step that we can do is to find the probability between -1 and +1. And that good thing is that if you notice, the function is between -1 and +1. So this probability will be equal to 1. The area under this range will be equal to 1. So whenever I ask you a question to you, which is beyond the limits, for example, it is -1 +1, and I'm asking you -10 +10, you have to think how to resolve it. So I showed red zones. Red zones means which we are not going to, where the probability will be 0, and the blue or green zones where the probability will exist. This is the, and I think you have studied probability yesterday, madam. So you have some basic concept. Probability is like uncertain, measurement of uncertainty, or measurement of something for the future. Okay, so you know how to resolve absolute function. For example, if x absolute of x is 1 equal to 1, so you will say that x will be from -1 to +1. So you will use your first semester calculus
Sir,
under. Yes.
sir, can I ask a question from previous slide?
Yes.
Sir, why we used -1 to +1 in the median instead of -half and +half?
In the mean case here,
Yes, sir.
because this is a lower limit. I'm just changing, and this is b. So whenever we solve mean, we need the parameter values. The parameters are the lower limit, which is -1, and the upper limit, which is +1.